You know,
So it's
I've been
looking.
these SWE benchmarks are a pain, and if you're looking for like suffering, the SWE is like the worst,
Oh, it
and
sucks.
it's so awful to work with, and
Yeah,
it's like so narrowly focused. Now the trouble with the SWE benchmarks is they're like a kind of benchmark that tries to do like one shot or two shot or five shot or whatever, and then say it's done. And
yeah,
to be honest, problems don't not all problems can be solved within five shots, but if you give it enough shots, anything can be solved. So essentially, those SW benchmarks are kind of meaningless because if you do it long enough, you can solve any problem, therefore it's 100%. But it doesn't measure that. It only measures the fact that you can do that for this really narrow part, set of things for a very short period of time, and that's apparently the state of the art. But
yeah.
it's measuring the wrong part of the state.
Yeah, I'm using it mainly for verification for the documents. So when you have something, it's able to learn and understand how to interpret what's going on. It may be a complete waste of time to be honest
Yeah.
with you, but
Yeah.
I'm finding it is helping because my main thing is take messy stuff and turn it into documentation. So I'm finding some learnings there, but yeah, it's
And,
not going to take up a lot of my time.
and what are you building this in?
Uh, um, Oh, I've got a full agentic some I've leveraged a lot of what you've built. So having a I've gone to nodes rather than a database just
Mhm.
to be able to handle the vector side of it. And then
Yeah.
also because I want both human written stuff and then I want the formal language. So I was able to confirm a lot of aspects like the token levels being able to have exact requirements that have to be done. Not quite 100% deterministic, but it's getting a
Mhm.
lot better than when
All
it's a
right.
lot better than when I type something is when you have the math-based formulas doing it.
Cool. Well, good
Yeah.
luck. Good to see you.
Yeah.
Um, Nick, what you've been vibing? You're big on the Rust these days?
Yeah, like right now I'm just at sort of an inflection point with the project I'm working on, just getting the CLI commands to actually work and like getting the schema down correctly. So I had some bugs doing that with the project I'm working on, and I decided, well, my Claude decided that it was smarter for me to have like a contracts repo to sort of have a universal source of truth for the various CLI commands that I'm pulling out of different smaller repos for the various uh, commands, right?
Hmm.
Because it was just running into some errors with that. So now I've gotten
You guys
past
been out
that.
here since I left?
Oh, sorry guys.
So,
I'm mute.
so yeah, I've gotten past that. I just need to keep working on it. Now it's sort of a simpler fix, but
Yeah.
should be able to run some commands. I got the auth working with it, so that's good. And it looks professional. I just told it to do it like Claude, the way that Claude Code does, and it seemed to understand that pretty well. Um, so it stores, and I've also got to add like a usage
Hmm.
command, and then I'm gonna, tell it to do it like Claude Code does with the usage in the UI. But it's got a pretty rudimentary UI right now, but it's yeah, like making progress.
Yeah. Nice.
This more thinking going on than
Well,
building shit,
the,
right? But
it's I'm in the same sort of boat. Building and creating. I'm a little stretched thin, and I got some travel coming up. I might be heading on a little business trip to the possibly the Middle East and India in a few weeks for some business. But what I want to show you what I'm excited about this week. And there's a crew, Roger and Doug and Howard and Gordon are at the CES show in Las Vegas, and we're launching, basically taking the Rue Vector stuff that I've been showing you guys over the last several weeks and popping it into appliance and on a chip. So you're getting a sneak peek of the new website, and this isn't meant to be like a sales pitch, but it kind of is a little bit. So. Oh, anyway, so the idea here is always on agents. So the always on agents are agents that run perpetually, right? These are agents that are essentially running and checking and doing and acting on a sort of ongoing basis, and that's focused on particular particular parts of these. One second, I hear someone clicking. It's just throwing off my thinking for a moment. All right, sorry about that. So when you run these agents, so think of like a trading bot. You've got different stocks you want to monitor, you got news, you've got political, you got climate, you got all these different things you want to monitor. Each of those things requires an agent to sort of focus and do those things. Now, if you were working and using something like an E2B or a cloud environment, like Cloud Run on Google, then you're essentially running these things somewhere around $25 a month for continual use. And that's the lowest end sort of one you can possibly get, which is fine for most things. So $25 to $50 a month to have these things running, and any given group of things require many agents. So as I said, different stocks, different things to focus on, different parts of your health, whatever it is you want it to monitor, industrial systems. Each one needs multiple agents to look at different things. So that becomes very, very expensive very quickly. If you had 100 different things and you were spending $25 a month, that you're suddenly $2,500 for those things, and 20,000 plus a year. So it expands really quickly. And if you use other resources that are always on but more optimized through this idea of spiking, you've got the ability to do event-based sort of access to the compute. So what that means is when something happens, the system can understand based on the structure of the algorithm. These algorithms are basically tightly packed versions of the things that I'm building in RuVector and others, that for optimization of vectors and attention and learning and kind of a nervous system of sorts that allows the system to basically learn by itself. So what happens is these systems can be placed in and around other things. So think of an industrial control system and how it operates, the flow of electricity, whether it's on, the flow of information or water, if it's a water-based sensor, and it learns the structure based on the correlation of other things around it. So if it's monitoring, let's say, a hydroelectric dam, it could look at environment. It could look at rain patterns. It could look at different sort of structures that essentially allow it to understand the kind of causal effect between various things and how it affects that particular thing. Now that's the crazy thing, if you will, one thing. So what this does is essentially learns from what's around. So it's continually learning, but it's not always running. So there's multiple cores that basically monitor the core sort of things it needs to know, and that's fed by a controller. And then when things are more important that needs to sort of understand or analyze in more detail, it can spin up sort of more capacity and use it as needed. But it's mostly quiet. So it's kind of where you think of like LLMs and monolithic models as the kind of brain. What this is the sort of nervous system that connects it to everything else. And this is something we discussed a little bit last week. It's that sort of ability to understand where and how things need to be routed to different places, and different actions and activities affect each other. So by putting that into either an appliance or in this case a chip, you're able to do that really, really, really fast. And you can get that sort of interplay of learning in incremental steps much more efficiently over a longer period of time. So what this does is says I use the baby analogy a lot, but the idea of a baby learning and adapting and growing, and then as it sort of has more sort of world experience, it becomes smarter. But that doesn't happen all at once. What happens is you can do this over an extended period of time, months or potentially years, using this sort of approach. Now the chip uses like a AA battery or whatever, and it can run for years and just always learn without being connected to any internet environment. It runs completely independently of a cloud-based environment, so it doesn't require traditional machine learning models from the cloud. It can just run its little device. So basically what happens is there's this coordination layer. The coordination layer essentially provides the sort of logic. Where is this going? If it's a prosthetic hand, it might look at the signal relating from the human it's monitoring in terms of the nervous system that exists within a human's sort of nervous electrical signature, and then it can automatically monitor and then recreate that signature based on just being in proximity to it and seeing it. So think of like a prosthetic hand and the ability to have no lag when you move your fingers, but also have an instantaneous result. One of the biggest challenges you have with things like prosthetics and robotics is there's this sort of this generally 100 millisecond lag. The 100 millisecond lag is right in that sort of window of what we can perceive. So it sort of gives this uncanny sort of feeling about these things you see. This allows us to work at 1,000, maybe more times faster than the human nervous system. So we can sort of act as a kind of bullet time where the system is able to sort of act and see these things faster than we can perceive them, which is a whole other thing. Um, so proportional intelligence, the system is really fast. It has a memory system that continually learns. The memory is the interplay between vector and graph-based structures, and then incremental improvements to them in the graph, and that's root vector. So the root vector components provide the ability to do reflex level. And you notice I'm using a lot of terminology like reflex and nervous system. That's intentional. I see this not, again, as the brain, but connected to the brain, but providing all the things that are important for the brain, if that makes sense. Outcomes, it understands causal effect. For every cause, there's an effect, and then it learns based on those things. It adapts, it loops, it creates that sort of observe, act, evaluate, and adjust loop. So the system grows quieter and more precise as it goes. This is a mock-up. I don't know. It kind of looks like, let me stop my screen for a second. I've been showing you guys. It's going to be something like this. So this is actually a prototype that my son and I built. It's got a screen on it. I've also was able to get it down to this size. I should probably turn this on, but basically, I can plug this in here. This is this box. There. So this box, it looks basically like at this point, I threw a yeah. I essentially it's in Chinese. I got it from AliExpress. Let's for my prototype. Just to be clear, that's why it's Chinese. But anyway, this thing packs a ESP32. So I needed to prototype, so I used an ESP32 to prototype the whole thing. But yeah, this basically runs the root vector learning system and a bunch of my other stuff. I packed this stuff as WASMs, and at which point I can run these on any little device. And this thing literally is like the size. It's basically a watch, right? It's the same size as my watch, but it's got the chip in it. So 256 cores. So 256 cores is crazy. So if you think of ESP32 being a single core, right? And this currently is an ESP32. It's a single core essentially. It looks kind of like this. And so you see this silver right here. So this is the core for this particular chip. And what's interesting here is the fact that what we've been able to do is pack 256 of these, 256 things. So think of the size of this thing, 256 of these things, how wide that would be or whatever, in the size of this little silver bit right here. Now that means we can amplify and have attention-based amplification of the signal on the chip as particular things are important. So it can speed up. Remember that bullet time I was mentioning about? So now we can adjust the clock frequency, and I could probably overclock the thing to 4 gigahertz. That gives me 256 cores that I can independently manage. Some cores working harder than others, sharing and interacting with each other in the size of a tiny little chip that I can fit in my watch. Now, it's not perfect for everything, but what it is good for is it's good for sort of the idea of reasoning. So if you need an event that matters, an event that is adaptive, that isn't always the same, that has variance, which are almost everything with any level of entropy would have some form of variance, right? So this is designed for the types of things that would need to adjust. A heartbeat, metabolic system, brain waves, the various, signals and wave patterns that exist all around us, and mostly wave patterns. The wave patterns are particularly interesting because we're now using a hyperbolic vector space. So the hyperbolic vector space is what I love to talk about, but it's round and there's a spot in the middle that essentially sort of forms the sort of center point on out. That is really well suited for wave patterns. So you can encode these wave patterns directly in that sort of interplay between the latent space, the space outside of the universe, versus the vector space, which is mathematically described. And the implementation of that, which is the graph structure of the things that I'm showing you to learn, the graph structure now forms the basis of a kind of living model of the thing in which it's trying to learn. Then you can simulate that. So now that you have that particular structure, you can say, give me every other structure that exists that are similar to it or in sort of various deviations of it. So the system focuses on what matters, but when it doesn't matter, it's looking at the negative space. And this is the strangest thing about this technology is when you look at the core algorithm that I've put into this thing, it's actually based on not on what the thing is and what it's supposed to do. It's actually based on this algorithm that's called MinCut. Now, what MinCut does is looks at the minimum sort of number of connections that something has before it fails. And that's a really simple way to explain it. But what MinCut really does is tells you everything it isn't. And once you look at things from the point of view of what it isn't, it gives you a whole new sort of way to sort of describe how to understand it, which is, I know, it's like counterintuitive. But this MinCut algorithm in particular gave me the ability to do that level of that measurement of what it isn't in a deterministic way. So that means I can always get the same answer when I'm looking at a particular problem. So it's kind of like the antimatter of a regressive language model, which basically tries to sort of appease you by making stuff up. This is the opposite. This is like it's yin to its yang or something. And so this exists essentially to sort of contradict itself, which I don't even know how to describe that in any way other than it seems to work better. Anyway, so where do you want to use these types of applications? Financial systems, I told you about multiple bots and correlations. I think infrastructure seems really logical. I can pack one of these things can fit in a light bulb. I can put one of these in every light bulb in my house, and suddenly I've got an entire house that is thinking, right? There's Wi-Fi in this so they can communicate with each other. There's no internet required. So you can literally create your own secondary AI network, a kind of secondary AI internet. This has the QUIC protocol for intercommunication, both short-term and long range. So what that means is, back to my analogy of light bulbs, I could have swarms of light bulbs in houses or cities or neighborhoods or whatnot, and those are all connected closely and can communicate and collaborate and learn and adapt and share a kind of collective intelligence, which is light bulb based. But those can also communicate with secondary sort of environments that exist further away. But the QUIC protocol provides a sort of eventual consistency of their communication. That means that if one goes away, the whole system doesn't fall down. So you can create these kind of swarms of somewhat autonomous living, like conscious constructs that exist in light bulbs. And I go
So I,
and this isn't my
I want
pitch,
to
by
talk
the way,
about light
guys.
bulbs, Ruth. I talk about drones and wearables because those two spaces need this kind of compute and are screaming for it. That's why all the companies that have tried to do wearable or tried to put a lot of AI on drones have failed.
Yeah,
So
it's
if it's as
and
small and fast as you say it is, it's perfect for that market.
it's super fast. So most of my metrics. So I'm doing really well with Rust, by the way, in just on CPUs. But I'm seeing like at least 100x improvement. So I'm comfortably in most things in nanoseconds, where in the CPU environment I was in sort of microseconds. Not that microseconds is a bad thing, but when we're looking at sort of energy or joule per thing, like per event, then the nanoseconds make a big difference because it's thousands or millions of times less power required to do the same calculation. Yeah, so to Guy's point, yeah, I think robotics in particular, drones. I'm cognizant, pun intended, of the military applications. I'm a pacifist, so you guys know. I don't really have a solution to that problem, just to be frank with you guys. Um, there can be great good from this type of technology, as there can be could be terrible things as well. So, I'm practical about that. Manjuip, how's it going? How's London treating you?
Hi. No, I'm basically back only on the third. All good. It's raining here. Um, I saw some scribbles. I'm just wondering.
Oh, do we lose him? Yeah, I don't know. So this Zoom is a little loosey goosey. I don't. That's my technical description of this Zoom setup. I've had it for months. I just need to reset it or something. Craftsman,
Yeah.
how's it going?
Hello. Yeah, I was actually working on a similar project. I'm working on embedded C using the Jetson Nano because you can pack a lot of GPU power in Rust. And I was using this heapless Rust framework because it does a phenomenal job on, like, you can literally go into the actual memories address of the GPU and in the CPU level as well, and that have been giving me some good results because I've been cooking in a project where I'm just experimenting with world models, and damn, it's good heapless models because the thing is you need to have an ingestion pipeline system, and you want to have a training space, and training space also is right. You can train the model in a place where there's sufficient GPU. We do know that to train models you need power, right? And to go back to inference in this one, I've been using this stack from called Heapless, and it's amazing.
Oh,
And
nice.
I've been playing with this framework. I'm trying to get my little bit of my car automated, right, using this Jetson Nano, and it is directly having SSH connection to my Mac Mini because Mac Mini consumes 40 watts power at minimum, and you can configure it to set like do not exceed 50 watts, and a car can easily generate 50 watts of car power, right? Like a typical phone charger itself generates 70 watts in fast charging, right? In modern day cars, and you can make your car so amazingly fast just by using in the ARM chips. And I've been experimenting with with the Apple M
It's
chips because the ecosystem is well established with Apple, so R&D is easier.
it's funny you mentioned power, and it's a lot of what I've been describing is, as you point out, is directly related to the idea of power consumption. So when you think of like a Mac Mini, for example, it's doing what, 500 watts? That's the power system in a Mac Mini?
No, it's 70 watts. You can configure it to 70 watts. Peak is 120 watts peak.
120 watts. Okay, so they're
120
actually.
minimum is 35 watts. I just set the hard cap at 50 watts. It's a really good article how we can set up wattage limits using the MLX library.
Yeah, those Mac Minis are spectacular. If you're doing anything involving Rust, you should have a Mac Mini. And if the trick to I think the trick to the Mac Mini is enabling SIMD. You're looking for AVX2 or 5. If you got AVX5, you're smoking. So the AVX, are you familiar with AVX, Craftsman? The
Yes. I've been messing with AVX5 and RDMA, so I can connect that to my MacBook Air.
And how do you describe AVX? It's kind of it's an accelerator for SIMD, I think. Is that the general
Yes,
idea?
basically for ARM computers or any computers in the world, you need to give an accelerated instructions. So for in a normal sense, what differentiates a GPU and a CPU is basically its instructions. As GPUs follow the laws, computers of a CPU, you just say like I have very specific instructions to just do matrix multiplication. So that's basically what AVX5 is, or the AVX set of instructions. That's what Ruben has been referring to. So based on the hardware, you can win for the same set of hardware. If you just set up your AVX, it can have entirely different behaviors.
Yeah, that's the hack. The two things that if you're doing Rust on a Mac, ask it to do SIMD, SIMD, and tell it to use AVX 5 is the most recent, I think. 2 is the most common. And that you'll see massive performance increases. It's crazy. It's the nuclear button. Create me the nuclear button, I think is the idea.
You
All
change
right.
that into BIOS, Rube, or is that
No,
firmware?
no. You just it's a compile. It's basically a optimization you do for compile time. So
Okay.
when in Rust, you've got the ability to compile the application specifically to the environment that it needs to run on. So when you so if you do a WASM, for example, I'm optimizing that package for basically a browser or environment that does that's self-contained. And but I can also optimize for like a GPU or a CPU. So as part of those optimizations, I'm choosing optimizations that give me sort of like an accelerator. This is an accelerator. It makes the thing exponentially faster at certain things.
Yep.
Yeah, it's cool. And I've been using a lot of it. All right, before anything anyone wants to say, I'm going to show you some stuff in regards to my Cloudflow V3 that I've been working on. But before that, if anyone has a comment or whatever, this is raise
Yeah,
your
the
hand and
V3.
yeah.
The V3 is very interesting. Well, what's the difference between the previous version and this new?
I rebuilt it. So the last one was getting kind of a mess, and it was 125,000 lines of code. It was hot. It was kind of monolithic in structure. It sort of grew from a branch, but I was experimenting, and it needed to be rebuilt. It worked. Like it wasn't the fact that it didn't work. It just was hard to build new things for, right? So now and it's popular, so I needed to I can't just haphazardly now go and rework it because I've got I don't know it's hard to tell exactly, but I think somewhere between 50 to maybe 75,000 active monthly users of the thing based on looking at like the npm library. So I didn't want to mess with those people if I didn't have to. And so I started on the sort of RuVector, what, 3 months ago, creating this kind of idea of a compiled um, vector meets attention meets a bunch of other things that run really well in sort of tightly constrained spaces. And that ended up working pretty good. And then I ported that into my Agentic Flow system. The Agentic Flow system is basically the system that I use to build and deploy my client projects. So when I'm building agents, that's my agent library. And so it's kind of it's pluggable. It's good for that. But the other thing I did in RuVector is I took a much more modular approach to each of the things I built, building them in multiple parts. So as very tightly constrained or bounded packages that I could intermix with other things as needed. Now, what that subtle change did is meant that the problems that I would create in certain packages, as you add and you make better, if you will, you're always adding a potential new bug or two. Those are now sort of contained within that particular package that I've compiled and don't affect anything else. So it now makes building really broad, complicated things a lot easier. So with all that in mind, I suddenly realized that I could create this modular, self-learning, attention-based vector, blah, blah, blah system that I could then apply directly into Claude Flow as a mechanism to learn. But what I also realized was the fact that if me and probably several 100,000 other people have this existing database that we've been creating by using Claude Flow in these projects that we've been using it with. And I could use that to pre-train new models based on what you've been using the platform for over the last several months. That ended up working really well. I then was able to take and create a pre-training system that basically looked at all that data that sits in like JSON and memory.db files, and then train based on the causal effect of what worked, what didn't, what were the errors, what were the repeating errors, how can we mitigate those repeating errors, and then the system now has the ability to then learn based on all the things you've been doing in that project, in my case, Cloudflow V2 and V1 over the last 6, I think it's 7, or my kids, I said 6 or 7, sorry guys. Anyway, whatever. Teenagers, I don't understand them. The thing that makes no sense to me. But anyway, and so at which point I totally lost my train of thought. Anyway, I'm going to show you what I built. All right, here we are. All right. So first thing you'll notice here is I've totally reworked the status line. So the status line is, well, I'm going to tell me about the status line. So the status line is pretty cool. Okay, so what the status line is doing is there's a daemon, they call it, and the daemon, which runs all the time, demon, I don't know, something like that, basically allows it to always run and look at the different parts of the system as it runs. So in this case, it's telling me like what GitHub branch I'm in. It's telling me where I am in the development of the thing I want to build. So I'm using the DDD system and ADRs to sort of keep me bounded within the things it needs to build. It's telling me the active swarms, the active tasks, the memory being used, things that are important for me to sort of monitor. But this is all potentially customizable. Tell me about the hooks. So the hooks are an interesting part as well, because as you're doing different development steps, you're invoking background workers. So the system now has a background worker that sits independently of Claude Code at all. So you can invoke these agents that'll do things like check your ADRs. They'll check your PRDs. It'll check for security, problems. And you'll see here as it finds new problems, your notification here will go from clean to dangerous or don't publish or whatever happens to be. There's a multi-step CVE as well. So if we scroll back up here for a moment, we'll see here that we've got pre-task, edit task, pre-batch, validates and does various things. We then have the ability to sort of define different types of neural structures, like how the tasks get routed to a different agent and how it explains this as the system works. Cloudflow is prompting the sort of system itself and telling it what it needs to know to solve that problem. So it might say that you've already solved this problem 15 times. Here's how you did it. So it doesn't do it yet again. It could prompt it to say something like, you've already built similar code in this particular file that you can leverage and not rewrite that thing again. Algorithms, it can mix and match. It understands the nuance of the environment in which it's in, and then it makes suggestions as it's sort of interacting in that environment. And that's all happening through the hook system. The secondary system is I've invoked a kind of magic word. So this is similar to this sort of ultra think capability, but what this does is you can do ultra learn, and what that does is it invokes the learning system as soon as you do it. So you might say remember, right, or ultra learn, refactor. Different keywords will then invoke much more in-depth multi-agent swarms, but they're not using your Claude Code credits because I don't want to spend more than I have to. These are all operating independently of Claude Code or the Claude Code API, so they're not burning through your monthly sort of credit balance, right? They're operating independently because I'm using all those things I showed you earlier. These confederate across multiple instances of your working environment. So if you've got different code spaces, different environments that you're running, they can share capacity amongst all of them. So you can have multiple code spaces. One's maybe sitting idle. It'll borrow that compute and run that for the background agents. It can auto optimize and LLMs, so it has the ability to sort of have sentence structure and speak very narrowly, only on the things that are important to it. In this case, your code base, but it's all built in the background. I'm using all the vector capabilities. Tell me about the vector capabilities. Yeah, so the
Dhruv, how
yeah.
does the federation work? So let's say I am using Cloud Code Web for some projects. Some I'm using on my MacBook, some on
Mhm.
CodeSpaces. I would be instructing it to use Cloudflow everywhere effectively when I'm initiating. So I'm just trying to understand how are there any constraints for the federation to work? That was number one. The
Mhm.
other question I had when you said you used basically all the projects that we've been using, all the background information, but how did you get that information? Like because we are
The
downloading Cloud Code onto our setup, right?
Yeah, so I'm not sure I fully understand the question. How am I getting the background information on the existing data that I'm sort of pre-training on, or what is it? Is that what you're
Yeah,
asking?
so you said that you use the background in data from the projects we have been running over the last 6, 7 months to pre-train Cloudflow when you rebuilt it, right? So I was wondering, is it a selected set of information that you had access to, or is it all of our information? How did you get that information? Like, because we are,
It's in your I'm not getting it. I don't see it, but
right,
you have a file in your system called memory.db
yeah,
and that memory.db file essentially stores all these sort of activities. And you can look at that if you want. It's a SQLite database. So you need a SQLite viewer to see that data. But once you see it, you've got the ability to sort of interact with it. Let me see if I can
that does
and
it
that
do a global install of Cloudflow effectively?
the MPX
Or-
should also do it. Yeah.
Monjuit,
The
And it's
I think Ruv meant the work that he had been doing on version 1 and version 2 over the last several months, not on the work that users
No,
of Cloud.
I can only see my own stuff. Yeah,
Yeah,
so
okay.
yeah, so just to clarify, yeah, I've been working on the platform. I've been building, I've been doing things, and as I've been saving all that information to the memory DB system that existed in Cloudflow previous version. Then what I did is I created a pre-training and migration tool within the system that essentially will migrate from the previous version and then pre-train based on that. But keep in mind all that data never leaves your environment. Like this is like optimized for like your own sort of environment. I don't even have any telemetry. That's why I don't know how many people exactly use it every month because I don't even report that because I think that's a potential security issue and I didn't want to be part of that. So yeah, it's as secure as you can get. You know, that's the key.
Can we
Stu,
ask when it ships?
it's V3's out. It's shipped.
I,
It's a little alpha, but
the
I haven't.
GitHub is still showing 2.7.
It's V3. It's the V3 branch.
I need the
Here,
tissues.
let me show you guys.
Sorry, maybe I'm
Um,
looking at the wrong thing.
yeah,
And
no worries.
how does the migrate
I haven't
work in that regard?
I haven't published it yet. It just to be clear. Sorry, what was that?
How does the migrate work for V3?
Yeah, the let me pull that up. All right, all right. I lost my ADR, so I had to I'm not sure what I did. The moral of the story here. One sec, implementation. Here we go. This is what I want to show you guys. My ADRs. That'll explain all my crazy. Okay, so as I was telling you guys, and I got a little sidetracked for a moment. Apologies. I've been using a ADR system. So what this provides the mechanism to do kind of a decision-driven or domain-driven design structure, right? So you can see here that I've organized it and I've got about 20 or so at this point. And this defines sort of the structure around how the system how the system needs to be built essentially, right? So you got testing and event sourcing and workers. So this will show the background workers and how the background worker system would need to build continuous monitoring for health and security. I think there was a question about the migration. How does the migration work? Migration. The migration essentially takes your previous system and looks at it and looks at predominantly at, oh, it's freaking out for some reason. looks at your previous work. So again, there's a memory in the system, in the previous system, that basically we were using to sort of, it was a more rudimentary version of what I have now, but it was better than nothing. It actually made a pretty big difference in the work that I was doing, that to understand what had been done and what was coming next. Then there was this hive mind structure that attempted to sort of commingle the various parts of what was happening in different agents and have them collaborate. Now, the challenge I had with the hive mind, at least in that version, was there was a kind of data leakage between different things that I was doing within the structure of project, and it would sometimes get confused by the things I'd already done and the things that I'd done a while back and the things I needed to do going forward. So anyway, to resolve all those things, I needed to create a new memory structure to fix all that. So the migration path here, back to that question, this is how you run it. Again, it's V3. So let me pull up the V3 for you guys. I guess that's what you guys want to see. NPM, I think I gotta remember, I'm gonna type this off the top of my head. Claude Flow CLI, here it is. Yeah, so there's a series of packages, and the series of packages all connect together, and you'll see those in my repo in the Claude. Where the heck is it? Claude @ Claude Flow, and we'll see. So each of these is a package, and these packages can all be run independently of one another. Well, somewhat independently of one another, but they can be plugged. There's kind of a plug and play approach to how I've made them. Back to the idea of, by doing it this way, I've quarantined the leak of bugs. So if I happen to break the embeddings one day, the damage will be small and contained within just the embeddings module that I'm working on, right? So so for example, this is how I handle the embedding system for the entire system, symbolics and all that kind of structure. It exists. And this can be used with other things if you want to. If you need a quick and easy embedding library that you want to use with an application to make it smarter and more capable or whatnot, and you can pop this thing in and just use it as a dependency. So it's kind of a pluggable component that way. Back to so the migration. Yeah, so I gotta update those instructions actually. It would actually be something like Claude Flow CLI, then the instructions. Yeah, okay, it is telling me that. Yeah, sorry. This is the migration. Let me pop that in the chat for you guys. It's alpha. I haven't technically released it yet. So when as Stuart pointed out, if you're installing Claude Flow Alpha, it isn't the alpha, it's the V2 alpha. This is V3 alpha. So you could do Claude, I think I did that as Claude Flow. I think it's Claude. Sorry, I'm going to pop this in the text. It's Claude Flow MPX Claude-Flow at V3 alpha. I know. You're right. It's shipped. I'm telling you how to. I'm telling you how to do it. It's shipped. I just didn't do like a blog post about it, right? And or put it on Reddit yet, or make it the default, which is probably what you mean by shipped.
Default.
Yeah, that's a big jump. That's a big step for me.
Yes.
I'm
looking forward to it.
Yeah, I'm close. There's a few bugs and queries. I've already got 2,600 or 2,500 downloads. And that's not bad for not announcing it.
That's ridiculous.
Yeah. I only published it an hour ago.
Does the CLI come with it automatically? Do you need to download the CLI separately?
The CLI is the core. It isn't the core, but it's the thing you need most. And the CLI is how you interact with the hooks and the MCPs. And essentially the init creates the sort of the structure. So when you go in, I'm going to go back here. Oh, wrong screen. Or I'll go to the screen, whatever. Okay, so when you go and you run the init, why is it looking? You're going to run something like this. I'm not gonna run it because I'm on the space. Actually, I might have another environment I could probably spin up here, and I'll show you how I'll just do it. Yeah, I actually have another code space handy. This is just a messing around code space. All right, so I'm gonna show you I'm gonna show you how to initialize it. Take a second to get this going.
You already ran QE Fleet against it?
Yes, yeah, of course.
Okay.
I got a plugin system. I'm going to make QE Fleet and a bunch of your guys' stuff official plugins for it. I haven't got to the plugin. There's a lot of stuff here to cover, but the plugins I built in as a sort of modular component that sits independently of it. So you have full hooks into all of it. You can do lots of crazy things with the plugins. I'll probably start doing plugins versus touching the core. There's too much risk in the core. Plugins is, the worst case scenario, I break a plugin. All right, so what you're gonna do here, I've already installed it, so you can see that I've got some files in here. I've been playing around with it a little bit. So yeah, I'm gonna write npx. Now there's two ways to install it. npm is a global install. npx is easy and it's kind of transient right now as I do these sort of alpha. So then we're gonna do Claude dash flow / CLI. And I think it's what is it? I gotta find where I put that. What version am I using? I want to give you guys the right version. 56 versions. Oh man. Okay. V3 alpha. That's what I'm. That's what that's what we're gonna go with. I'm gonna copy this into the. What's going on here? All right. So then we do @ because I'm gonna use an @ symbol and I'm gonna pop that in there and I'm gonna do init and I'm gonna do init to win it. No, I'm gonna do force. Okay, so this is what I'm typing. So this is gonna basically force the installation, and this is telling me I want this version. I know I'm baby steps for me from this one. Oh, maybe it isn't this one. Or maybe I broke it.
Well, whilst you do that, I think someone was asking, like, can we quantize it beyond what Cloud Code does? I guess the best answer to that, in my view, is that it kind of incorporates all of Roof's projects, whether it's Roof Vector, HNDB, all those capabilities. They are all embedded within Cloud Code, which is obviously not, sorry, in Cloudflow, right? Which is not in Cloud Code. That's the base difference, actually. To be honest with you, when Gemini today told me and gave me a new terminology for your work, it's a roof technologies. So I was doing some project, so I decided to call all of your bit as roof technologies and to go along with some Azure function and Azure bits and another. That's a good, interesting perspective about the whole ecosystem that this is forming.
It is an ecosystem. It's I look at it like a constellation, like purposefully as a constellation, right? When you look at all these bits and pieces, oh, I'm forgetting. It's telling me I'm an idiot. Your command. Okay, yeah, I'm an idiot. I forgot one letter. Yeah, it's a constellation of stuff, right? And you can see like I've got all these different packages and components that I'm putting together. So all right,
this is latest versus alpha. The latest is the right one for the V3 CLI.
It would appear so. Let's see. We're gonna check that. So what we're gonna do is we're gonna do version, and I'll do alpha, and it's 56. All right, and then we're gonna do latest 56. They're the same. So looks like latest it is. I'm gonna pop that in there for you. And I think I can also do npx Claude -flow at v3 alpha, and I'm gonna do init and I do force. Let's see what happens there. Yeah, that works too. So that looks good. Now I've got my dangerously skip permissions, so I'm gonna start that. Now the thing I'm looking for here is, all right, I've got, all right, so you're gonna know works. Oh, someone's got a hot mic there, guys. I'm gonna mute you guys. All right, so the thing you're gonna notice, you're gonna see this right off the bat, right? If that doesn't work, you know it doesn't work. You can customize this. The idea of the status line is to give you a running start. What I would suggest you do is customize it to the particular requirements of your environment and what you're building. Measure the things that are important in terms of what you're building, how far you are in building those things, action, important action items, memory learnings, whatever it is that it's important to you. And this asks the system to customize it. It'll figure it out. It sees the hooks. There's a really detailed claude.md file here. The claude.md file tells it everything it needs to know about the system. Here's how you spawn a swarm. Then the next thing you're probably going to do is you're going to say spawn a 3-agent swarm. Let's see what happens. Now, if it's working, we should see a invocation. That's a good first message. Let's see the mesh coordinator. Yep. So it's used. Okay, so we saw the mesh coordinator. It did that as a pre-hook. That's good. It hit it. It's good. It's running in the background so we can do other things, and it should stop. Oh, I got an error. Oh, no, it's not an error. Okay, that's actually a message. Okay, so what you're seeing here at the very end is one of the forms of its reasoning. If more work is needed, the request was to spawn a 3. It gives a summary. So this is early. It didn't really tell. It's not doing anything. So it's not exactly giving it a lot of guidance. But as the system grows and adapts and becomes more aware, those are the messages that are being infused into the system. Now, those messages are not actually coming from Claude Code or Claude API, the cloud. Those are coming from the learning system that underpins the environment. So you're not burning. It's a secondary sort of introspection into what's happening and what's important to guide it in the right directions. Right. Back to what I was describing earlier. It's using the concepts of what it isn't and versus what it needs to be to guide it. I know it's a little weird, but that seems to work pretty good. So now it came back to life. I used the same sparse spiking approach that I was telling you guys in regards to the chip. I figured out how to implement that within Claude Code, so it sits and waits. But then the agents, when they're done, they come back and bring it back to life. That also cuts down on the amount of churn and the amount of the amount, that Ralph Wiggum thing that's all the rage right now, where you keep it in loops for all those times. The problem with the Ralph Wiggum is it burns it's a token burner. It just burns tokens for no reason while it churns and asks, are you done yet? This just waits, and then when it is done, it says, I am done. Right, and that's the critical difference here. All right, what do we got here? Yeah, so the agent's working. Yeah, now you're ready to rock and roll. We've got the thing working, and you can start asking questions. You've got different hooks, so you got all my different agents. You've got different ats if you want to do like goal. You've got all the popular ones. I've optimized all these agents and skills. There's a whole collection of skills relating to just V3. You'll see V3 skills here about DD architecture. So if you're looking to implement in the same style that I'm implementing, you can basically use these V3 skills. So the V3 skills like domain-driven design. This tells it how I handle those DDDs, and those are directly the DDDs you're going to see in the actual system itself. So if I see here the DD domains, this is telling you how far along you are in the development of your application. You can adjust those, and this skill essentially does that. You've got integrations, you got performance, you've got security. Every step along the way, the system is asking itself, am I secure? So basically there's a kind of background process, and that is handled in here, and you'll see helpers. These helpers are all the things that allow you to sort of invoke secondary agents that do different forms of guidance. So this would be a guidance hook, or GitHub integration if it auto commits to GitHub or has performance optimizations that are happening in the background. Every time something's compiled, you might want to kick off a performance optimization. That's just a hook. Those hooks, I gave you a lot of them because I do a lot of this sort of thing, are all in the settings.json. The settings.json here describes all your hooks, when they work. You can see that, how we're inputting them, that it's based on task or bash or command edits, before or after. So this is user prompt submit, session start, and then you can see how I'm adding information or providing different forms of guidance. So the stop hook that we just saw here would be based on this. So it's just, giving it reasons and other information. This works out of the box. Oh, I don't know what the routing is. Haiku. I thought I fixed that. All right, I gotta fix that. I see an issue. I don't want to use that older model. I'll fix that right
So
now.
this include root vector and agent extent?
It's totally it's all built in. So in this case, so let's go back down. Tell me about the vector embedding and self-learning systems of Claude Flow. And keep in mind, this is a remote install, so it's not my Claude Flow repo. So this is very much what you would see. It's clean. I haven't really built anything in this repo. I'm just using it to test the system. I did find a minor error. So I'm gonna make sure the settings that JSON uses the most recent Opus 4.5 model. All right, we'll fix that. All right, so now it's doing what's it doing over here? It's looking at all my various stuff. I've actually integrated this one, to be honest, I've got root vector in this repo. Yeah, so that might throw it off. The root vector. So I'm using it as an upstream in this repo. I was going to do some network development of some sort. I was looking at doing high-speed networking just for a project. So that's why I set this one up.
So do we just install this? We don't install Agentic Flow, root vector, root LLM.
You get it all.
Will pull everything.
Everything,
including the CLI.
Including the CLI and the hooks and the MCP server. And there's a whole MCP server. Let me show you that. And I'm using the latest the latest approach to MCP servers, where you don't load all the context window. So this is the lightweight MCP that they came out with. Oh, it failed. Wow. Well, now what's going on? Oh, it's probably using the wrong. It's using the wrong address. I haven't. It's cached. I think this is at latest. I think that should solve the problem. I gotta push the. It's cached an old version or something. You can tell I'm debugging. You're gonna run the errors as I debug. That's why I'm not quite ready to. Oh, it's still failing.
When do you think you're shooting to roll it?
It'll be done when it's done. Soon. I don't. It's little things like this, right? So this is this will take me 2 seconds to fix, but regardless of how hard I try, there's always regressions, right? And anyone that says you can't build without regressions is much more talented than I am. So yeah, this is minor though, but you can tell it's mostly there. You could use this in this current state, unless you're looking to use the MCP tool for some reason. it would work just fine. The hooks all seem to work. So when we do what do we do here? MPX Claude. There's an @Claude flow / CLI at latest, and we got hooks. So yeah, we got tons of hooks here. This is the part that's probably the most interesting anyway. So if you want to learn about a particular hook, you can go in here. Let's do a pre-train because that's a useful one. And we'll do pre-train. Oh, it is pre-training. All right, so we just pre-trained. So we looked at 84 files. We did pattern extracted. We looked at trajectories, and it took 1 second. Now we can build agents. Okay, we'll do that. So now we'll do hooks build agents. So follow the little guide here. And we created some agents for coder, architect, tester, architect, reviewer. These agents would be might be secondary, but I did anyway. What else we got here? We've got metrics. Let's see what the metrics look like. So the metrics, these are telling us similar to what we see in the status line, total patterns learned, success, failures are what you really want to find anyway. Here's your routing. This will improve, but this is training it to route more efficiently to different agents as needed. We've got this is telling me how many times I've executed. So this is a relatively new repo, right? So 128 is actually pretty decent at this point, but I only created it earlier today. Average risk score, success, and there's a lot more we can find out here. What else? Transfer patterns from other projects. So you can do transfer learning, which was an interesting thing I was looking at. So I might want to combine multiple repos and the learnings from the one repo to another. So let's say I'm using multiple projects together, and I have 2 different Claude flows that we're running. I can transfer the knowledge from one and combine it with another. I don't have the source. I don't have that handy, but that's a really nice feature. Route. This is my routing. I don't have a task for it, but I could give it a task. These are hooks that you'd run it as hooks as part of the hook system. Yeah. So yeah.
I think I mentioned it like 3 months ago. What about community sharing? So you talk about sharing between your repos, but the idea that I had long time ago was to kind of create for the agency or the agent group or the community, so we don't keep making the same mistakes over and over. And I know that you probably share important information about how you program or how your agents are working, but I think it will be useful for the community.
Are you suggesting that maybe we create some shared models that you can import?
I mean, yes, because you're already working and you are finding patterns or coding improvements, and then if you share, like if you are migrating, if you can migrate that as a main source of knowledge for the community, will be awesome. So we can learn from other programmers or other people. That was my idea like 3 months ago, but it was too raw at that time. It's just an idea.
It's a good idea. I think there's lots of opportunity to share our knowledge, our code, our components, but that does raise an interesting point. I can pre-train different models that you could import into this that would be like optimized for certain things. And that could be really easy for me to do here. I've already got that sort of transfer concept from different environments. So now that I've got that, the source could literally be an export, and the export could be in a form that strips APIs, PII, and anything that might be questionable to be shared. Maybe we'll have the ability to have configuration that strips out the data based on nothing to a lot. All right, so here's how I'm gonna do it. All right, so we're gonna go here and we're gonna create a new ADR for the where was that feature again? It was the transfer, I think it was transfer. So we're gonna prove that for the transfer hook feature
Because
that
I guess
also
what
yeah.
no, I guess what is getting learned from the system is not related to personal information or APIs
Yeah.
or anything that can be shared. It's more about knowledge.
Mm-hmm.
So that I'm wondering because this fits exactly with the idea that I was having. So that now that you have the migration option, is very quickly and easy to implement it.
Args for the different levels of I love obfuscation. It's a good word. Obfuscation, PII redaction. Oh man, redaction and other forms of anonymity. Does anyone actually know how to spell anonymity? Or anyway, it should figure that out. Anonymity. It needs a spell check. All right. What am I missing here? What else do I need to do? I need to and include both import and export options. Let's include, I think I've got this built already. Can we use the IPFS option capabilities from Vector for an optional export import location for a common plugin store, right? IPFS is free. I can store we can store these models on IPFS, and then we can create an index of them, and you can just import the models from anyone that shares them on if you optionally export it to IPFS. It'd be a really easy, cheap way to bootstrap a plugin store. All right, so create a new ADR. Okay, blah blah blah. This is what I'm doing. So it knows so it's got the ADR system built in. Now I'm back in my Claude Flow repo, and it it has the skills and it has the experience, and it knows, and it should take a look at my ADRs and create a new ADR. Now I could probably do this as a GitHub issue as well, but because I have so many, I'm just storing it in that folder. I don't want to put too many things onto the GitHub issues. But in the integration folder, no, not integration, it's in, here it is, implementation, ADRs. So we should get 21 here in a second. But what it's doing, it's good, is it's looking at what I've already built, right? So rather than having to go look through all my code, which is problematic and might miss things or whatever, it's just looking at a much smaller subset of the things that are meaningful for what it needs to do. In this case, it's looking at the ADR, which was the ADR for the original memory system, which let's go take a look at. And looking at unified memory. Yeah, let's take a look at that. So this is the original memory system that I did on the third, and it's looking at the integration of SQLite, AgentDB, and a hybrid sort of mix and match, memory service interfaces. So AgentDB is kind of like the root vector component that I sort of made more accessible. Performance targets, updates that it made, some more updates, CLI integrations. So it can see that. Not that much. It's not the most complicated thing because I've built all these components separately through secondary integrations that I've done, right? So by sort of compounding and mixing through these different sort of combinations, it just makes it easier to integrate and doesn't have to get bogged down on all the craziness that makes it work. It just needs to do it for the things that are important for the application that I need it for. And you can see it there. Given the complexity of the memory system, that was a pretty simple explanation of it. Right, we're creating 21. Let's see so this takes a second to do it. Don't need any swarms or anything to probably do this. Now we could do a swarm to actually, to do the documentation. We could do a swarm to implement it, which I might do just to make sure everything's working. I'm using Claude v3 to build Claude v3. Now the core difference in what I'm doing with Claude v3 that you're not doing when you use this independently of this branch is when you go into I got a different command line system, and I've got a different settings.json. So the settings.json is using a combination of the old Claude flow for certain things I still need it for like hooks, because I don't want to break if I use the core of v3 and I break it, then it's going to break periodically. And the two are compatible. So I just use the old version because for what I needed for metrics was good enough. But then I integrated the background checkpoint manager. This checkpoint manager and the swarm hooks and swarm monitors, these are specifically optimized just to do the development within this particular project. So these are happening in sort of secondary workers. So the system can spawn primary agents that you would use Claude Code or Claude for, but it can also spawn secondary agents. The secondary agents you'll see in the helpers folder here. And these are the SH files, right? So it's monitoring the health. It's learning this is calling this the learning capabilities, secondary learning. So this is optimizing it in the background. So this folder is probably the most interesting folder you're going to look at because it's like basically how I'm building the system. So understand this folder, and I've given you this folder in the other implementation, the real implementation. And where I gotta find that screen. Here we go. So when you go in the Claude, you'll see a folder called helpers. These aren't connected. They're not connected. I didn't, because it's just too much. I don't know if you want to use GitHub or if you want to do secondary self-learning or whatever. So what you're going to do is you're going to point Claude at this folder and tell it to update your hooks. Literally. And then, or ask questions. How can I use these to improve my development flow? And it's going to look at it and it's going to, oh my God, it can do all kinds of stuff. This is the stuff that you're going to want to do. So basically point it at this folder. So I'm going to do that right now, actually. Review, and I'm back on the, actually, I'm not going to bother that. I'm just going to drag it. I'm going to put that here, and tell me what it can do. Something like that. All right, while that happens, I'm going to go back here for a moment, and we'll see if this thing is back. It is. So now we've got a transfer system. Thank you, Jose. We want to read it first. Now the IPFS, I think, was an interesting addition. That's scope creep, but I haven't launched publicly yet, and probably why. Claude v3 neural learning system generates various patterns, trajectories, team collaboration. Additionally, we learned, okay, this is the context. It's what it does. This is the PII, it's proprietary code patterns. So we can we can potentially export proprietary code patterns, but it's good to know that we can address them. All right, we're gonna create a little store, if you will, on IPFS, that sort of file-based blockchain thing. Decisions. This is the decision matrix architecture. Yeah, it looks pretty good. New command line hooks, transfer, export. Okay, these are good. We've got, what's missing? I think. Yeah, we're missing the MCP integration. Tools. That's why you read these things. If you're not reading it, then you're just vibing. Strict level 3. Paranoid. I kind of like that actually. Okay, so we got anonymity or anonymization levels. They figured out how to spell it. Preserves most data, only removes PII. Minimal. I think that's a good baseline, to be honest. I don't think there's ever any reason to share PII ever for anything. So, and if you want fake, then you can recreate it later. Standard. This strips out emails, IP addresses, API keys. This one does usernames and emails. I think we should have API keys by default. I don't know. Well, depends how you want to export it. Like, I guess if I certain cases I might want API keys that are local API keys, and I don't really care. They're like dev API keys that aren't meaningful. All right, I'm gonna keep that. Level 3, minute maximum privacy for public sharing. Okay, that looks pretty good. It's generalizing. That's a smart way to do it. So we keep the essence of the learnings, but we don't give you the details of how it was learned. Which is perfect, I think. And
Yes.
paranoid. Yeah.
That's how it should be.
What's that?
Yeah, that's how it should be. I mean, you don't have to find a way. I mean, there's some security bugs that some people find, the other are still implementing, and that will be a very knowledge valuable thing, no?
Very much. Like imagine like universities collaborating on quantum research. Imagine medical firms collaborating on diagnostic information without sharing all the patient information. Imagine the ability to share optimizations for anything we can possibly want to optimize. We just create a mechanism to learn what the thing does, then obfuscate anything that might get you in trouble, essentially from regulatory standpoints mostly, and just the ethical reason to do it. And then the ability to share that in a way that can then be imported into other systems that are capable of learning and adapting and taking that knowledge and enhancing it further.
Yep.
So now with this rule, you just bring your own PRD and you build the ADRs within.
Yeah.
Okay. Yeah.
Well, that you bring up another interesting point. I wasn't even thinking that level, but that's you could train the system to understand the DDD structure, the ability to have that kind of domain structure that works optimally for a particular problem without describing how you came up with that structure, but showing how it's optimized and works, because the system's capable of obviously measuring those sorts of things. So yeah, that would allow you to do specs. And now if you want to do a spec and you're saying, okay, I need to build a e-health system, and I've never built an e-health system before. I know generally what I need to do, but I'm not specifically knowledgeable in e-health. Then I can then go and say, well, here's an e-health trained model for the development of platforms to do this particular thing, and then I can pop that puppy in there and say, here's what I need. Here's my PRD. Go create me the rest of the scaffolding I need to go and build this thing optimally.
That sounds like a blend with agent Accent and the simulation of the business. Also, you do.
Well, that's that's the other part. That's exactly the other part.
Okay.
Yeah, so we can simulate all this as well. So there's a whole simulation system. All right, I added the that looks good. Sauteed for 1 minute and 56 seconds. What do we got going on here? This one, no, this is my migration I was showing you guys earlier. Okay, update ADR, and I mean, just remind me, did we update the init settings.json to use the latest? I'm using Opus 4 here, but I'm going to make sure everyone gets Opus 4. Opus 1.5. I don't want to publish too early. I got to make sure that the stuff that I'm doing is included. But you can tell I'm using it. It's working. A few quirks here and there, but I'll figure those things out over the next day or so. But yeah, if you do have bugs, just do issues. I'm sure there's bugs. And what I haven't done, as you can tell if you look at the CLI, is I haven't actually exposed all the crazy. So I'm not sure how to expose that without looking like when you do the RuVector version, like I've got a RuVector CLI and tool that does all this RuVector stuff, but in the more crazy sort of out there sort of descriptions. This is meant to be more accessible. So I'm not going to go and talk about crazy, science fiction sounding things if in this particular sort of positioning of the tool, if you will. But there is a lot more that it could do. You're going to have to dig and find those things. Now, here's the other thing you want to try, just to let you know. Obviously, I built it for Windows, so all you Windows fans out there that were complaining about it not working in Windows, you can have all the learning tools directly in Windows now. So let's just do. It's my ESP32 folder. Yeah, let's put it back again. npx at Claude Flow. Actually, I think I've already got it installed, so we'll do DSP. And I'm gonna do so. Okay, so yeah, I'm not running it in this folder. I forgot where I want, but regardless, I can npx Claude -flow at I gotta do front if we're getting at CLI at latest init force. Yeah. There we go. Looks like I might have a problem. All right, what did I do? Of course, you always discover. All right, let's go. I'm gonna fix that too. Update ADR. Windows, of course, it worked great until I wanted to give you guys a demo, but Murphy's Law. It's an alpha.
Demo god.
Yeah. Dragon, how's it going?
Oh, nice. I'm building my own V3, based on yours, so it's going quite well. Need to do some testing, but maybe also during the weekend we'll be ready.
Yeah. And you had 40 centimeters of snow, is that what I hear?
Yeah. Just before our Christmas to make it everything white and with, tired hands of shoveling. But
yeah, that's a lot.
Nice exercises, yeah.
Yeah, that's like what?
We didn't have like a 5 years this kind of snow, so I remember the earlier, but it didn't snow that much. Now it's again, it's good for land. It saves the crops for the sub-zeros, so that's also a good thing, and kids love it.
Well, it's good to have the work. We go shoveling snow is a good workout for you. So back to the hooks for a moment, guys. I know there's a lot of stuff in here. It's more than I could possibly tell you guys. There's just so much. But here's the hooks. So remember I told you to do the help folder. These are the different helps. So you've got your life cycle hooks for stopping and starting. You've got your pattern optimization for performance tuning. You've got the ability to auto find duplicates and merge patterns. You don't want it to be a mess, so it keeps things clean. So it optimizes based on HNSW vector search. So I vectorize it. I'm using all the crazy sort of hyperbolic vector structures, all the things I like to talk about, all packed in there. I go and create a 50 paragraph description of it. Pattern promotion after 3 successful uses. So this is essentially self-reinforcement learning. You can benchmark, and so it can auto benchmark itself. You've got the different swarms. You've got the ability for the swarms to have comms. So the swarms are able, in the background process, to communicate with other swarm members in a back channel. So it's like a back channel to communicate different things that the swarm needs to do. It has event stealing. Agents in the background can then steal the events that are related to things that they're already working on that are more directly related to those things that they're doing versus other agents who are doing adjacent things that aren't sort of aligned correctly. So then the system can then send message to message. This is the craziest thing you need to watch. There's an internal freaking dialogue between all the agents that are working and how they collaborate, and it's completely fascinating to watch. And it usually degrades into this pseudo code-based sort of weird communication channel that is basically just a bunch of weirdness that doesn't make any sense to me, but seems to work.
Quick question, Ruth. Do we need the human in the loop on that? Do we need to monitor?
No, this is completely autonomous. There's no human in that. There's no human in that loop. You are the human in the loop from the point of view of the Claude UI. This is happening. This is their own little swarm club that happens in. You can monitor it if you want. Just you can be part of that if you want to. Create a Slack channel and have that all happening in the Slack channel, and you can communicate with them. It's weird. And I don't pretend to understand exactly what's going on here. They basically have shared learning, and they collaborate, and they all learn off each other. They hand out tasks. Then we've got the daemon. This basically runs all the time and facilitates all the things that are happening in the background independently of Claude Code. So it's a separate agentic network that exists independently of Claude Code to help Claude Code. We've got checkpoints, so you can see I can automatically checkpoint and put everything into GitHub based on certain hooks, and these are really useful. So you can do instantaneous rollbacks, rollback 5 minutes. Every edit is auto staged and committed, or not, depending on the level of check-in you want. So you can customize that. You've got the security validation. So as new edits are completed, you can choose things like a stop or like a finished or whatever, a post-edit hook. You can then invoke a security scanner that they'll do a security scan independently of Claude again. No Claude Code credits used on this, and analyze the security standpoint of your system based on all the craziest cutting-edge security stuff you could ever imagine. But I'm not going to create a billion paragraphs to explain, but just take my word for it. It's crazy. And then you get your ADRs that it can track. So as ADRs are completed, it'll auto update and show in the status line system that your ADRs are complete, and then it kind of tells you where you are in your development. It goes from 0 to 100%. Yes, you got a whole bunch of things there. You've got performance. You got workers. The worker system allows you to invoke background workers that I haven't even thought of. Let's go. Let's go. What kind of crazy background workers should we create using? All right. So then we've got guidance. So this is the guidance and routing system. So what this does is in between your tasks in the system, you can customize it to give different forms of guidance, guiding it in terms of what it should do, how it should work, what's wrong, what's new. But that happens inside of the sort of structure of the system. And again, it's fed from the Roux Vector or Claude Flow core, so it doesn't use any of your tokens. I've included the ability for you guys to have a language model embedded directly in Claude Flow that you can run locally without inducing any costs. Now, I don't need that to be broadly smart, right? This is a perfect example of a targeted small language model. I just need it to be smart at doing the allocation and operations of this particular system. So I can pre-train things like Gwen 5 to do that really well based on all my data training systems that I pre-train on, and then I use that as the guidance system, which works really well as well. All right, what do we got here? Great question. Here's some frameworks for autonomous background intelligence. We can create Ghost Coder, silently analyze the unfinished to-dos and comments. We can create an archaeologist, gets rid of basically old code. It monitors recent edits, regression profit. Okay. Runs lightweight fuzzing on chain functions, prediction workers, scans NPM cargo for security advisories. Like, all of them are amazing.
Wait,
Okay.
will we need to go out and create the PRD? Because I was just thinking as you were showing this, the only thing missing is a PRD checker, right? So
no, you don't need a PRD checker. I'm using ADRs. PRDs are basically a functional abstract. You don't need the PRD is nothing more than the initial input to your everything else that needs to happen. It's the first prompt, if you will. But beyond that first prompt, you don't need it. Right?
Well, I was thinking from a standpoint of making sure that whoever wants to build whatever they want to build is architecturally sound, makes sense, and is
the system magically does that. I'm giving you that. You guys assume it. I just assume everybody wants that, and that's what the system does, right? It makes your system. It's almost like I assume that 99% of the people that use the system will never, will never go to this level of sort of customization. So for those 99% of the people, it just has to work and be better than using Claude by itself, right? And just by installing the init and just starting to work with it, it'll do pretty much everything you need. Now, what's interesting over time, because the system has a tendency to skew towards the things it knows or has been told based on things like the Claude code, it's gonna give you and optimize itself because it knows that it's got 12 self-learning hooks. Right. So the AI just sort of naturally uses the things it knows it has available to it. It knows it can do swarm and memories, and it knows that it should never do certain things, golden rules, that kind of thing. And so when you start using it, you'll notice that it has a tendency to use the London School of Test-Driven Development. Right. You may not know that you need to use the London School of Test-Driven Development, but because that's an inherent testing skill, it just uses that. And people are now using the London School of Test-Driven Development, which works a lot better than not using it.
So what if you wanted to build that rubber? I just saw it on the last screen. It was like a rubber duck simulator or what have you. If you wanted to build that based on.
Yeah. So here we go here. All right. So my top 5, I can do all of them, but I'm going to say, let's do the top 5, create a ED for each, and spawn. I might be late for a call, guys. Let me just check my calendar quick. Nope, I got a few minutes. All right, let's do the top 5 and spawn a 5 agent swarm. I don't know. So
this is crazy. This is awesome, bro.
Yeah, so then we sit back and we'll see what happens here.
Would you recommend this for any general project development as well? I was say from a PRD to write the.
I use it to clean up my hard drive in Windows. Right. And then I monitor my registry system, and then it sends me messages when the registry needs to be slightly adjusted. You can use it for anything, right? If I can use it to keep my Windows registry clean, then I think what can't you use this thing for? All right, so let's jump back to the other one for a sec. I was working on some things here. All right, made the following updates. The updates all right. This one, it was that. All right. 21. Okay, test, validate, deploy a hello world Seraphina model as the Genesis export to IPFS. How's that? Seraphina model. We're the first model is gonna be called Seraphina. And if you guys know who a Seraphina is, then you'll know why I call it why I called it that.
Low
she's
Nexus.
yeah, yeah, exactly. She's my six-wing goddess. All right, so I'm gonna build. First thing I'm gonna do is I want to know the damn thing works. I'm not overly concerned about exporting the data from this particular repo because I share it anyway. So, you know, giddy up. Let that do its thing for a moment. All right, what we got here? We've got, that was fast, built in like 2 seconds. 5-agent swarm, okay. Test and validate the the workers. So I created 3 background workers. Once I validated these workers work, I'll add them to the hooks. And that'll essentially, you know, then those will run every time. And I just need to do one final validation of that. And all right, oops. Range is running. See what we can see underneath the covers here.
Why did you choose 5? And was it because of the odd number? And why only 5 agents?
Well, we're vibing. I don't know. I didn't realize it was going to take 30 seconds. So I just limited it. But yeah, it's 5. No particular reason. It suggested 5, and I went with it. I didn't even look that closely at what it was doing. Ghost coders, you know, hallucination detector, impact radius calculator.
Roof, quick question on your status line. You had talked about redoing the status line a month or so ago. We talked about maybe having the system be smart enough to understand how much capacity was left and use that when it decided how many swarms to implement so that it would fully utilize and get things done. Have you played with any of that in the V3?
I have, and you'll see 15. So you're currently limited to doing 15 concurrent agents at any given point by Claude Code. Now I get around that by doing all those background workers. So 15 is meaningless at this point. So, but 15 is the amount that you can directly do in the UI. So that's why I sort of made it 15. But you can do thousands. I did a what was it the other day? 100. I think it was 200,000 concurrent agents on a single chip, tiny little chip dosing.
The question is having it automatically decide what's the optimal amount to deploy to leverage whatever machine it's running on to speed things up without making things unstable.
Depends what you're doing. A lot of these a worker versus an agent, they're both agents. I just wanted to make a distinction between an agent and something that was kind of a task sort of element. In the worker, although it is an agent, it can do incredible things because it's using the headless version of Claude Code sometimes and whatever it needs to do. But it essentially does, it's part of the hook. You finish a task, you write a file, you update something or whatever, and then the agent can be fired. It can operate in the context of an invocation, like you use a certain word, ultra learn or whatever, and then that worker goes and does whatever it needs to do. So the idea is again, it's sort of a task-driven worker that's optimizing. And think of like, I think of little robots in my head sort of moving around and doing stuff, you know, and floating around in like some futuristic sci-fi movie kind of thing, right? That's what I'm envisioning on that. All right, so what we're looking at here, and I'm almost out of time here, but what I'm building here, which is actually ended up being a really cool idea and from Jose, is this idea of creating a mechanism to export and share my type of, and I don't even know what they call it, but my type of learning model, right? This kind of graph meets vector style learning model, and then anonymize it and share it to an IPFS. So that's what we've devised. And then what we're going to have is we'll have a mechanism to query our little free app store, and we could share different models amongst each other that we can then import into Cloudflow and bootstrap our environments. And I'm gonna
Awesome. And
Yeah,
what,
Jose,
what,
that
about-
was, that
what,
was awesome.
yeah, and what about learning from each other, the agent?
Yeah, well, I've already the Federation, so
Okay.
the Federation already works. The Federation, and that's why, remember earlier I was telling you about my light bulb thing. That's the Federation. So they can train. I can train all kinds of things, and it has various forms of agentic flow is where you want to look for that stuff. If you're looking to do the real crazy, like you're going to use agentic flow. It's in there under the covers. You got to discover it. In agentic flow, it's out there. Everything's hanging out. You can just point it at it, and it'll find all the crazy. And the most crazy is MPX root vector. That is the tip of the spear for crazy. So depending on if you're going to a business and you're going to show them something, maybe don't start with the crazy. Start with things that are understandable.
Yes.
Let's see. Well, I'm just watching my screen. Let's see what do we got here. Oh, it's still HiveMind sync is still running. It's still optimizing itself. Okay, so what we're seeing here is it just basically figuring itself out for a while. Yeah. Well, that. What do you guys? I rambled again for 2 hours. What are you guys thinking? Am I crazy or what?
Amazing. Finish ship.
We want to get that crazy too.
Well, you guys can try it. I showed you the command. Again, there's bugs. I'll work those bugs out. And if there's something, if there's an obvious bug, like a deal breaker, let me know. But seems to work for me.
Just point Claude at it and ask it do the same for my project.
Yeah. Start with the helper. The other thing you can do, point it at tell it to investigate the source code for Claude Flow. After you installed it, just tell it to look at its own code base, and also get it to tell it to look at the Claude code base. And when you combine those two sort of deeper looks, it'll set you down the crazy rabbit hole.
Alrighty.
All right, that's it for me. Thanks everyone.
Looks amazing. Can't wait, man. Thank you.
My pleasure. All right.
Thank you, Ruth. Thanks so much.
We're doing the Hackerspace tomorrow. If anyone wants to show off anything, that's your moment to shine. Reach out to me or Rob, or just show up, and I'm sure we'll get you going.
Where do we see the link for that?
I know. I'm gonna make a permanent freaking link. Yes, I gotta do that.
So how do we, if we want to go, where do we go tomorrow? What time?
I share it on the WhatsApp group and my LinkedIn and a few other places. And maybe tomorrow it'll be the one where I create a permanent Zoom that never changes, and then you'll just store that in your calendar for every Friday. But I've yet to create it.
Yeah.
So
yeah.
tomorrow.
But you also have made some changes to the website, so we can put the link to that also on the calendar, right?
Yeah, let's do that. Okay, so tomorrow, 2 things I'm going to do, and maybe I should do that right now. But 2 things I'm going to do. I'm going to create a permanent Zoom meeting, and then we're going to update the website, and then you can just find it there. That's going to happen. All right.
All right.
Thanks, everyone.
Make it happen.
All right.
See you tomorrow.
See you now. Bye.
Thank you.
Okay.
Cheers.
Bye.